Hey, good morning, everyone. Thank you for joining. Just want to confirm that you guys can see my screen. If you want to just drop that in the Q&A window or the chat window, that'd be great. Perfect. Thank you. We'll get started here in just a few minutes. Thanks for being on early.
When you're driven to get the job done right, the days are long and the miles are many. You can't accept good enough, and you don't believe in limits. To make something truly better than before, to make it last, you never settle and demand a higher level of precision. Day in and day out, we're on that path, advancing filtration science, developing superior filtration technologies to keep you going, to ensure your performance now and in the future, to protect, to go further, to keep you going. Run cleaner, longer, with the certainty of filtration science.
All right. Hello and welcome to our Fleet School live session today. As always, it's a privilege to be spending time with curious minds such as yourselves and bringing you a series of these interactive sessions where you guys can listen in, learn, and engage from the filtration science experts here at Fleetguard. For those of you that have not had the opportunity to meet me before, my name is Jay Stevenson. I am the North America training leader for Atmos Filtration Technologies and our Fleetguard brand of filters and coolant products. I'm based here in the Nashville, Tennessee area. I've been with the company now coming up on 12 years and really excited to spend some time with you guys today. As you can see from our screen, our topic today is lube filtration. We're going to cover a little bit of heavy duty engine oils, kind of explore the world of engine oil, talk about why oil needs to be changed. And then we're going to highlight the role that lube filters and filtration play in protecting a diesel engine. Do want to remind you guys, everybody is in participant kind of listen only mode. We will have plenty of time, hopefully at the end, for questions and answers. So I would encourage you guys, if you want to ask your questions as we get to the end, that works. If you've got questions you want to drop in there as we're going along through the material, so you don't forget. I'm bad about forgetting to ask questions. Feel free to drop those in as we move along through the course of the session today, and I'll try to make my way through as many of those questions at the end as possible. And if I don't have a definitive answer, I can certainly follow up on those questions and get back to you guys with a response. So please avail yourself to ask questions as we go through the material today. So we'll just go ahead and jump right into it. In order to really fully appreciate the broad topic of engine oils and lube filtration, we need to kind of take a step back and just talk about the evolution of lubricants for a minute. After all, oil contacts more critical components of the engine than any other fluid. And today's diesel engines are designed to meet the latest emission regulations, provide users with better fuel economy than ever before, and also enable longer oil drains and these longer oil drain intervals than ever before. So lots of very positive things that have happened across our industry over recent years. And a key ingredient for these things to be possible are these advanced lubricant technologies. And I really hope that one of the themes that kind of shines through as we do these Fleetschool live sessions month to month is that changing engine technology does have a direct influence on the fluids, be it fuel or coolant or engine oils, and certainly filtration. It has a direct influence on those things. And so kind of what we're saying there is that filtration and fluids, they evolve right alongside the evolving engine technologies. So in order for us to set the stage for some lube filter discussion, we are going to talk about heavy duty engine oils for a few minutes. What is it? What does it do? How is it made? We're going to kind of answer some of those questions. So functions of engine oil, this is really high level stuff here. Stuff you guys probably already know, but covering it from a very high level. Oil is the lifeblood of an engine. And just like us, an engine is going to stop working very quickly without the right amount of it or the right quality of it, right performance of it. Those things have a direct impact. But how exactly does it help the engine? Well, engine oil provides protection against the four major causes of engine breakdown: heat, deposits, sludge, and wear. And in each of these protection modes, there are a number of different ways that the oil goes to work. The obvious one that's given away in the name, lubrication, right? Oil reduces that metal to metal contact by forming a film between moving parts within an engine. It's going to reduce friction as the engine runs. It's going to help prevent wear, help reduce heat being produced by the engine. But there are several different ways that oil protects an engine. Like we just said, it does actually absorb some of the temperature generated by an engine. So oil actually does perform a little bit of cooling, even though the cooling system and coolant is kind of really the main driver there. It does perform a little bit of that temperature disbursement, and particularly in parts of the engine where heat's being generated from that combustion process where maybe the coolant isn't exactly reaching. So think about pistons, bushings, crankshaft components, some of those kinds of things. We'll talk more about this on an upcoming slide, but oil is designed with additive chemistry that's going to enable the oil to actually clean internal internal engine components by dispersing and passing along contaminants such as carbon residue, through the lube system that's going to be removed by the lube filter. And in addition to these items, oil also seals critical engine components to help maintain compression. Oil prevents corrosion of metal components within an engine over time. We're just scratching the surface here, but you guys get the picture. Oil plays a super important role in the performance and health of a diesel engine. But what is actually in today's lubricants? So just a quick breakdown here. Really, any reputable engine oil that's sold today is going to be made up of two main components. You've got the base stock and an additive package. Now, typically the base stock is going to make up between 70 and as high as 99% of a packaged engine oil. The additive package makes up that other 30% to down to as little as 1% of the oil. Only about, when you think about kind of the big picture in the world, kind of market of crude oil, only about 1% of crude oil that passes through US refineries is converted into a base stock oil product. The vast majority of crude oil is turned into other products such as gasoline, kerosene, jet fuel, asphalt, etc. There's lots of other things that use it, lots of other industries. Only about 1% of crude oil that passes through US refineries is converted into this base stock oil product we're talking about here. To shed a little more light on base stocks, here are just a few notes to consider. Base stocks are the main ingredient in a lubricant, and they have significant impact on performance. Physical properties of the base stock affect certain characteristics of that finished good oil product, like things like viscosity, pour point, volatility, just to name a few. So it does play an important role in the way that finished good oil, heavy duty engine oil is actually going to perform on the engine. There are three main refinery processes for turning crude oil into a base stock. The first process is called solvent extraction. That's essentially where you're going to separate good molecules from bad molecules. There's a process called hydrocracking, which is a process for converting bad molecules into good molecules to be used. And then lastly, there's a process called synthesis, where you've got molecules essentially being built from various chemical reactions. So there's kind of a few different ways to go about generating this base stock product. The American Petroleum Institute, we're going to mention that name a few times today, API, they group base stocks into 5 categories. Groups 1, 2, and 3 these are your petroleum-based base stocks. And even out of those, really group 1 and 2, those are going to be more of your mineral oils or conventional oils. Groups 3 and 4 are considered more of your synthetics. And group 5 is also considered synthetic, but it's of the highest quality, and it uses base stocks that are not included in any of the lower categories. So it's kind of the top echelon of quality and performance, those kinds of things. More expensive, though, obviously. We'll talk more about this in a bit, but the move for lubricant blenders, people that are actually generating heavy duty engine oils, they're going to continue to, what we're seeing is a trend of continuing to choose the higher quality blends. So using more of those group 2 and group 3 base stocks, that's more of what we're seeing. That's what the trends are kind of lending to as these oil chemistries continue to evolve alongside these evolving engines. Now, that's kind of the base stock side of things. On the additive side of things, these additives, they're very important as well, because each one of these additives is going to perform a very specific task that helps maintain the overall condition of the engine and can prolong its health. And in fact, the right engine oil design can decrease overall engine wear, can increase the time between drain intervals, and it can improve the working capabilities of the engine. So that 1 to 30% there in that additive package, again, depending on the blend, it is really that secret sauce that's going to ensure your engine keeps on running smooth for the rest of its useful life. Additive packages for engine oil are very complex in the way they're formulated. They're designed to meet very specific engine and performance requirements for each and every engine OEM. And it can take months, even years of engineering, field testing, to fine tune that right formula before it hits a retail shelf that you guys would go out and either sell or purchase. So there's a lot that gets baked into the chemistry and formulation of today's engine oils. But let's tackle one of the big questions about engine oil. Why does it need to be changed? Why do we have to service this stuff? Why does it go into the engine looking nice and clear and come back out kind of that black and brown coloration during a service event? Well, most people probably never stop to think about it much, but it is a good question. And there are several different reasons that a lube oil will degrade over time, but we're going to focus on the main offender for right now. As we know, engines work by combustion, and that combustion process generates heat and flames. The hot temperatures produced in this combustion process, combined with oxygen, eventually break down lubricants in a process called oxidation. Oxidation is the main limiting factor of oil life. Let me say that again. Oxidation is the main limiting factor of oil life, meaning it also is the main limiting factor in lube filter life as well. Remember those additives we just talked about a few minutes ago? Well, those additives have a useful life. One of those specific additive functions works to keep contaminants like soot and wear metals, any kind of debris in dispersion or suspension in the oil, right? So kind of floating around in the oil within the lube system. But once that additive package is worn out, the oil can no longer keep those contaminants in dispersion or in suspension. And those things begin to kind of stick together and glob together and combine and agglomerate into larger particles, generally in kind of the 15 to 30 micron range. And that's going to cause that oil viscosity to increase, and so that oil is going to get a little thicker. And in other words, the oil is going to stop working like it's supposed to within the engine. And you're going to see an increase in wear start to occur in the engine. So oxidation, that's the biggie as far as limiting factor of oil life. There are other issues that can cause oil life to deteriorate prematurely. For example, you could have coolant leaks, excessive oil consumption, high sulfur diesel fuel, incompatible oil types being used, fuel dilution, water contamination, soot contamination, dust ingress. There's lots of other things that can lead to oil life being shortened. But in a best case scenario where the engine's running the way it's supposed to, that oxidation process is actually why that oil begins to break down. So we've talked about what lubricants do for your engine, how they're formulated, and what causes them to break down over time. But let's talk about how oils have changed over time, just as a big picture, in a big picture look here. So as we mentioned back at the beginning of the call, advanced lubricants, they played a big part in helping engine OEMs meet emissions regulations, both for today and, again, looking ahead for the engines of tomorrow. And we can track this progress over time through the way oils have been categorized. If we go back to the late 90s, the oil category of the day was CH4, replaced by CI4 in the early 2000s. That was replaced by CJ4, which stood in place for about 10 years up until more recently being replaced by the CK4 and FA4 oil categories. And each of those advancements, each of those category jumps or transitions represent a change in oil consumption and or oil composition rather, and additive chemistry. Of course, each of these being formulated to be suitable for the engine technology requirements of their day, of their time period. Today's categories with CK4 and FA4 oils vary in chemistry and behave differently to previous engine oils. The lower viscosity performance characteristic is a big part of that differentiation. So why low viscosity products? You might be wondering why is that such a big deal? Well, viscosity is an engine oil's most important property, right? There's lots of things we said are important to a heavy duty engine oil, but the viscosity is a big part of that conversation. Switching to a low viscosity oil can offer really unprecedented fuel economy benefits. There's a couple of things going on here. One of the things that kind of is rolled up in these fuel economy benefits, we do see lower greenhouse gas emissions, measurable emissions, carbon reductions. Again, the only way to lower CO2 levels in this manner is by improving fuel economy. So we're going to burn less gas, less diesel fuel, and so that helps us hit that lower number. And secondly, just direct fuel savings. So a switch for an example, a switch from 15W40 oil to 10W30 oil can, or 15W40 rather to 10W30, that can result in up to 3% fuel savings, which, again, if we're putting our head in a Class 8 truck, that can be thousands of dollars of savings over the course of a year. So you start to see some benefit here from these lower viscosity oils in the marketplace. Now, some of you may be sitting there or maybe have talked to folks where they've got concerns over wear protection capabilities of lower viscosity oil, right? So, hey, if I'm thinking, hey, this oil is thinner, maybe I'm not getting as good of protection against wear in the engine. Really, newer trucks are equipped with advanced applications, as the materials that are being used, such as polymeric coatings and components like DPF, which can enhance fuel economy and provide better friction protection. Additionally, more OEMs are choosing these API CK4 oils for their factory fill. So more engines are actually coming out of the factory using these newer oils anyways. And some are even opting for the FA4, which is a little bit more of an experimental category. We're going to talk about that in a second. So, even though these are newer technologies, these are what the OEMs are using. This is what they recommend. Importantly, when it comes to viscosity, thicker oil is also not always better. I think that's the assumption. Well, if it's thicker, it's going to protect better. That's not always the case. Instead, a balanced formulation that is proven to provide engine protection while also offering fuel economy benefits should be prioritized. And even though it may sound like it, guys, I promise you, I'm not a lubricants engineer. If you're curious to learn more about how oils are classified and governed by both national and international standards organizations, I would encourage you to check out resources such as the American Petroleum Institute, API. They're going to be able to provide much more detailed explanations of these different oil categories. But I did want to dig a little deeper on CK4 and FA4 categories for 1 minute because that is the world we're living in today. So, really, as you think about these newest oil grades of CK4 and FA4, these were released back in December of 2016. So, all the way back to the very end of 2016, really as kind of a 2017 model year changeover. They replaced that older CJ4 category that came out in 2006. These newer oils enable diesel engines to run more efficiently, which helps promote better fuel economy and again reduce measurable emissions. That's the name of the game these days, guys. That's what everybody's trying to shoot for. Plus, just in general, the improved chemistry is designed to help the oil last longer than ever before. I thought this was a great fact. As you think about kind of what are the differences in these oils, new oils versus older. CK4 and FA4 oils have up to 60% better resistance to that oil oxidation, kind of that limiting factor of oil life we talked about earlier. 60% better resistance to that oxidation process than the previous generation of oil grades under CJ4, which we just saw a couple slides back, right? That's the main limiting factor on lube oil and lube filter life in today's applications. And you can kind of start to understand why this is a major factor behind the movement of engine OEMs, people like Cummins, Detroit, and others to continue pushing oil drain intervals further and further. We're out to really long drain intervals, what's possible anyways, than people would have ever even thought was possible, 10, 15 years ago. It's just really changed dramatically. And we'll see an example of that here in a little bit. Speaking specifically though, CK4 oils, they're especially effective at sustaining emission control system durability, where you've got particulate filters and other advanced after treatment systems. That's what they're designed for. CK4 oils are designed to provide enhanced protection against oxidation, viscosity loss due to shear, oil aeration, as well as protection against catalyst poisoning, particulate filter blocking, engine wear, piston deposits, degradation of both low and high temperature properties, and soot-related viscosity increases. So lots of things there that it's designed to help with. FA4, these oils and kind of that sister category there, they're designed with really a lower high temperature, high shear viscosity, even more so than their CK4 counterparts of the same grade. So that's going to improve efficiency even more. Newer engines also run at higher temperatures, which can stress those conventional, kind of more legacy formulated lubricants rather, by accelerating the oxidation and degradation of the oil. So, FA4 oils may provide additional value from that perspective. Just one watch out here though, FA4 oils, this again, that was a little bit more of an experimental category when they came out. They are not designed to be backwards compatible to pre-2017 engines. So It's always wise to consult with your engine OEM's guidelines on which lubricant technology is safe and approved to use. Don't let me be the expert there. Always consult with the engine OEM. Now, I've referenced API a few times and just wanted to highlight the way to know how an oil is categorized. So, oils displaying these API certification marks are going to prove that they meet the performance requirements set by both US and international vehicle and engine manufacturers, as well as the lubricants industry as well, on top of that. Now, the main thing to note is that the oil, again, whether it's whether you're buying this in quarts or gallon drums, however you're getting this fluid, you're going to see these SAE labels. So again, Society of Automotive Engineering (SAE). You're going to see these labels indicating what their service category is. So for a CK4 or FA4 oil product, you should see these little donut labels with the category and also the grade or viscosity included in the middle of the circle. So that's our donut. Like Homer would say, there's our donut right there. And that's going to start telling us a little bit more information. So the category and grade included there in the middle. And, roughly 70%, as you kind of think about what's out in the market today, roughly 70% of the heavy duty engine oil purchased in the North America market today is a 15W40 grade. But as the industry continues to shift towards these longer service intervals and more fuel efficient technologies, you can expect to see more lower viscosity grades in the marketplace. 10W30, I think I've got a slide that's going to show some of these things, but 10W30 is the fastest growing grade in the industry today. There are even 5W30 and 0W30 grades present in the marketplace now, which I know that probably raises some eyebrows for folks, but this is the future. This is where things are trending. Just a couple of slides here. If you look at CK4 oils, I just wanted to give you guys some examples here on the screen. So right there, again, the little donut showing up on the product label. Just as an example, we've got API service CK4. So that's telling us really the category of oil that we're talking about. And then there in the center of the donut, we've got our viscosity, right? So 10W30 product. Like we said, CK4 oils, these are really designed for 2017 model engines and moving forward, or tier 4. If you're in the off-highway space, you can see some of the kind of more technical information there in the bullet points I've got listed. They, as you see in the red at the bottom, CK4 oils exceed the performance criteria of previous categories, right? So CJ4, CI4, CH4, and kind of going backwards through the previous categories. Just another look here. So again, FA4 lubricants. We can see there, these are describing certain oils specifically formulated for use in specific types of engines, 2017 and newer. This is a little bit more of an experimental category. There are fleets out there using FA4 oils, but the vast majority of people in our market today are using CK4, some limited use of FA4 oils. So just wanted to give you guys a snapshot there as you see some of these products out in the market, something to be looking for if this is new information to you. So what's next? What's next in the evolution of heavy duty engine oils, right? If you're looking at the timeline there, you might be thinking, well, we're coming up on, maybe 10 years, getting close to 10 years of these products being in the market. And that's right. Proposed category 12 or PC12 is going to help OEMs and fleets reduce carbon footprint even more. The experts in this space say that there likely will be 2 new categories coming around for 2027, much like what we saw with CK4 and FA4. One of these will probably be a backwards compatible product. The other one likely will not be backwards compatible, will be a little bit more of a new model and forward kind of experimental type of oil. Now, as we stated, there are still some folks that, again, are a little skeptical maybe on these thinner viscosity oils, but the data really bears out that the performance improvements are tangible and worth it. Since the fuel savings benefits of lower viscosity lubricants are considerable and OEM specifications are being introduced to support their use, the growth of lower viscosity grades should be significant over the coming years. So, I've got a little snapshot here. You can kind of see a forecast looking out into the future of the next handful of years of these different grades, different viscosities, and basically the perceived adoption of these products in the market. This is maybe more information than you were expecting to get on heavy duty engine oils today. I know this is a little bit of a quick plunge into that discussion, but I think it's a really interesting topic. I've included some information in this presentation that you can go back and reference. We are recording this, so if you'd like to go back and look at this again, please do that. If you use QuickServe or some of those online tools like that, there's more information about lubricants and heavy duty engine oils out there. I would encourage you to dig into that stuff and be the expert here. Lubricants impact the design of not only engines but also the filtration product offerings, as we as a filtration manufacturer are looking to help vehicle and equipment owners reach that lowest total cost of ownership possible. And so, speaking of filters, we are going to get into some filter discussion today, I promise. We're going to switch gears and talk lube filtration. We've kind of danced around this interaction between filters and oils kind of the whole time, but what exactly is the role of a lube filter? Well, earlier we said that oil is the lifeblood of the engine. And if that's true, then think about the lube filter being like the kidney of the engine. Its job is to remove impurities and contaminants that cause engine oil to degrade, just like kidneys go through and purify your blood as your blood circulates through your body. And so, if we keep that analogy going, if your kidneys stop filtering, your body is going to have problems. And if your lube filter isn't doing its job of keeping the oil free of contaminants, engine oil or engine life rather can be significantly shortened as well. Now, the engine's lubricating system, it is a closed loop, meaning oil begins its ride sort of in the sump, and that reservoir for oil, the oil pump is going to suck that oil up. It's going to pressurize it. It's going to send it through kind of up to the lube filter. The filter is going to remove those microscopic particles of contamination, any kind of wear particles or debris, before pushing that clean oil to all of the various internal parts of the engine, things like pistons, bearings, valve train components, all that stuff to lubricate it so it can all move freely. Now, when it comes to filter performance for an engine oil filter, there's really three major performance categories that we want to concern ourselves with: efficiency, capacity, and flow restriction. And as we stated earlier, a filter's responsibility is to remove unwanted contaminant, but there's some, kind of parameters to that we've got to specify. We need to specify how good the filter is at removing those contaminants, how much of that contaminant can it hold before the filter is full and starts to plug, and how easily does the filter allow oil to pass through without being too restrictive. So, the rate at which particles of a given size range are removed, that's referred to as the filter's efficiency. Filters with a low efficiency allow more contaminant to stay in the system. That can lead to increased wear. And filters with a higher efficiency tend to plug up and restrict more quickly. So it gives the filter a shorter service life. So some things we have to pay attention to. Capacity, the amount of captured contaminant a filter can hold is known as the filter's capacity. Sometimes you're going to hear this referred to as dust holding capacity. And just know that dust, that's not necessarily a real world thing. That is really tied more to industry standard test methods used in lab settings where you've got basically certain grades of test dust used to determine a filter's performance rating. So it's kind of more a brochure test type of information. But by design, a filter's capacity should be large enough that the filter lasts the duration of the customer service interval. So they're not having to change filters sooner than the prescribed oil drain interval. And then lastly, you've got flow restriction. So flow restriction, again, we're taking into account the amount of restriction or resistance towards the oil trying to pass through the filter. And with lube filters, that's a really important metric because it's really critical for the oil to flow as quickly and freely through the filter as possible, because we want to make sure that all of those critical engine components are being lubricated. That's especially important in cold weather conditions, right? So when you think about an engine cold start, where that oil may be behaving a little thicker than it normally would in hotter temperatures, we want to make sure that when we start that engine up, that oil is not having to fight too hard to get through the lube filter to go and lubricate all the engine components. So that's an important metric for us. But overall, right, a well-balanced designed filter should kind of look at all three of these things and try to really optimize, a balance between these performance characteristics. So just a couple quick notes back on these things. So efficiency, an oil filter is designed specifically to remove particles of sizes that are going to cause noticeable wear or abrasion. This is particularly true for some of those power cylinder components, things like bearings and cylinder wall surfaces. We don't want those things to be scored up or see any kind of wear. For today's diesel engines, hard particle contamination in lube oil, we're really looking at particles like 10 microns to about 30 microns in size. That's really the range of particles that we are interested in, that we know cause critical engine component wear. And that's what we tend to look at. Most lube filter efficiency requirements tend to run around 99% efficiency at 30 microns. That's pretty typical. If you guys have been on any of the trainings I've done where we cover fuel systems and that conversation, you'll know that the particles going through a modern fuel system can be much, much smaller, much finer, all the way down to low single digits. 4 microns is pretty typical. So part of the reason why we're not trying to capture stuff that small in the lube system is that the pressures are much different in a high pressure common rail fuel system than a lube oil system. And as a result, we're not really, and of course it's a closed loop as well. So we're not quite as concerned with very fine particles on a lube system. So lube filter performance tends to not be focused on super high efficiency, just to be clear. Moving on, just back to flow restriction just for a second. It is important to get flow restriction correct for the application. If there's too little restriction, that means we're not really capturing the stuff that we need to capture, and that could damage the engine. But too high of a restriction means the filter is not going to allow that oil to flow as easily, especially during cold, like we said. And so that can cause some problems as well. Higher restriction on that lube filter is also going to kind of sap a little bit of power from the engine because it's having to work a little bit harder, and that can have a negative effect on fuel consumption even too. So just a few things to point out there, as you think about designing a lube filter, filter media is really important. Filter media has a big impact on the performance of that product. And so, there's several choices of filter media for lube oil filtration products. Generally, the fiber size in the media is what's of interest there because that's going to impact that flow restriction on the filter. So smaller fiber diameters of the media type chosen can result in a more freely flowing filter, which is why more of the newer heavy-duty engine applications, particularly that we touch as Fleetguard, use more fully synthetic media types like melt-blown and nanofiber medias. So we're able to still get really high efficiency, but we're getting that low flow restriction. So if you're familiar with Fleetguard products, you may know the Fleetguard Stratapore filters or Fleetguard NanoNet filters. Again, you're getting high particle removal efficiency while maintaining low flow restriction. So that's a great combination of technologies that we make possible through our filtration science methodology and approach. And then back to capacity. So I mentioned we'd see an example of these oil drain intervals and how much longer and further out they've been extended than years gone by. And a filter's capacity is directly linked to kind of the service life. And so a high capacity filter, that's going to enable the operator to go beyond conventional service intervals. And if we look back in time, we're seeing here some lube filter part numbers on Cummins heavy duty engines. So kind of your X15, ISX, your classic semi-truck applications. If we go back in time 10 or 15 years, it was very typical for those engine applications to be, even in a best case scenario, you were set at 25,000 miles for changing your oil filter. Obviously, as these newer oil categories have been introduced, we've got better resistance to oxidation, better chemistry, better formulations. Those numbers are climbing higher and higher, higher than they had ever been before. And so now, where we were at 25,000 miles for a light duty drain interval back in 2010 timeframe, we're up around 75, 80,000 miles for the same type of engine technologies that are out there. So really amazing, and this is kind of off on highway conversation, but in the off highway space, getting into big high horsepower engines and things like that, it's not uncommon for us to support customers that are exceeding 1,000 hours over that 250-hour range that was typical back in the day. We're pumping people out very, very far due to the technologies, and I think it's pretty amazing. It all has to do with the advances in lubricant technology, engine technology, and of course filtration technology too. So think about your own personal life, your own personal vehicle. I remember growing up, you would change your oil every 3,000 miles. That's kind of what you did. That was the standard. Now, most passenger car applications of newer vehicles today, routinely go well past double that number. 7, 8, 9, 10,000 miles before needing to change oil. And again, it has to do with the evolving technology. So pretty amazing. When it comes to the Fleetguard product portfolio, there's thousands of lube filter part numbers available today for newer engine applications. We've got a lot of different part numbers and products to support those customers. But lube filters, they come in all sorts of shapes and sizes. Everything from cartridge filters to your traditional spin-on steel canister style filters to even centrifuge or centrifugal filtration on those lube filters. So lots of different technologies, and we're just going to take a quick look at a couple of terms as it relates to filtration that maybe you've heard before, maybe don't know the full in and out, but just to cover a couple things. So spin-on lube filters, they have gone some evolutionary changes over the years. We've really moved from more of your full flow applications to bypass applications, and then more recently to combination filters. And then filter media changes and all sorts of things have happened. So, lube filters have undergone a lot of evolution in the last 10, 20, 30 years. You may have heard the term full flow or bypass before, but just explaining what those mean. So a full flow filter works just like it sounds. The entire flow of oil passes through the filter on its way through the engine. So in a full flow filtration system, the oil passes through the filter. It's going to retain those larger particles. It's going to send that clean oil to the engine, and works pretty simple. In a bypass filtration system, what you have is you have a small percentage of that overall amount of oil that's in the lube system, and you're going to send a small percentage of that oil through the bypass filter, and in addition to a main full flow filter. So that bypass filter, it's designed with a really high efficiency, so great at particle removal, but it's also designed to not flow oil very quickly. And so again, we want to balance those things. So you would use a bypass filter to basically super clean part of the oil while the rest of that remaining oil is going through a full flow filter. So they kind of work hand in hand together. Now, it's not always cost effective or easy to outfit an engine with multiple lube filters. And that's kind of where combination filters came from. So we were a big proponent of combination filters back in the day. And this is essentially where you're taking a full flow and bypass filter and combining them into a single product. So Fleetguard combo filters, they combine full flow and bypass into one filter unit. This is stuff we were doing back in the 90s and on a lot of Cummins application, but other applications as well. And so we're going to super clean some of that oil through a bypass section of stack disc media in the top part of the filter, where the rest of that oil is going to flow through our full flow cartridge or Stratapore media. And so it kind of in one unit, you're able to do both of those things. So a pretty cool piece of technology that we still sell today. We've got a lot of products that still use that kind of architecture. And part of the reason for that stack disc was really good at cleaning sludge. And so as engine oil kind of degraded and would break down. You'd have sludge that would form in the lube system, and that stack disc was really good at cleaning that stuff. Well, again, as engines evolved, the lubricants have evolved. We don't really see engine sludge nowadays. Like that oil doesn't really get sludgy, or it's not supposed to. And so that's where our lube filters evolved as well. And so what we did is we essentially took kind of the same architecture from the previous slide here, and we basically removed that stack disc media in kind of the top portion that was acting like a bypass, and we actually replaced it with our nanofiber. So our NanoNet nanofiber that has been so effective in our fuel applications, we replaced that stack disc with our NanoNet. And so it works really great because what it's doing is it's essentially still giving that really high efficiency of particle removal. So we're capturing stuff at a really high level, but also, where you would see kind of the high flow restriction with stack disc, we don't really see that anymore because the nanofiber, we get those really fine fibers, really small fiber diameters. And so it acts like a full flow, even though it's filtering kind of more like a bypass. And so it's kind of the best of both worlds. And this is why, we've got engine OEMs using these lube filters on applications. So if you're familiar with like the LF 14000 NN or LF 14001 NN, these are some of the products that use kind of this architecture. So, we've kind of talked about a lot of different things today. Just to hear what an engine OEM has to say about the topic, look at this quote from Mark Ulrich. He was the director of customer support for Cummins. Talking about the environmental and TCO impacts of oil technology and lubricants and all these changes here. And he says, with oil changes routinely costing $350 or more for the oil filter, labor, and disposal costs, and a typical over-the-road trucker performing 2 to 3 oil changes per year, we see the potential to significantly reduce costs and downtime, with some customers needing an oil change only once a year. So I would maybe encourage folks that are on the call, if you are somebody that has a fleet or maintains a fleet or sells to a fleet, it really isn't a benefit if they are still kind of adhering to old change intervals, using older viscosity oils. If they have newer applications, certainly take advantage of these evolving technologies where you've got lower viscosity grades that are designed to be more fuel efficient, last longer. Make sure they're using the right filtration product that's going to jive well with that, and they could essentially reduce the amount of times they need to bring that truck in for oil changes. So just a couple of things to think about. Before we conclude our time today, I wanted to highlight a couple of options for the folks that are maintaining diesel-powered trucks or equipment, or again, maybe you're selling to folks that are that could be interested in saving money through lowering that TCO as it relates to their oils and filters. And the first item here is our Fleetguard Monitor program. If you have not heard about Monitor before, it is a fluid analysis program that we offer through Fleetguard. It's made possible by a third-party company that we partner with called Polaris Laboratories. They are an ISO accredited global laboratory company. We've got several kit part numbers. You can see some of those on the screen here. And essentially what it is, it's a fluid sampling program. So you can take samples of your oil, send them off for quick analysis, and in a matter of a couple of days, you'll have your results back, and it's going to tell you about the condition of your engine oil. If you need help kind of interpreting some of those things, we can help with that as well internally here. But it's a great program. If you're familiar with our discount program, our rebate program, these are part numbers that are included on that as well. So just another one of those things to ask your customers about, or if you're on the program, something you can purchase on our program. And I know oil analysis, this isn't new. This has been around for a long time, but I would just say if you're interested in using a Fleetguard approved solution to see what's going on inside your engines, I would recommend checking out the Fleetguard website, and you can see some of the information we've got published here about the Monitor program, or reach out. I'd be happy to send some information your way. And the second option is part of our product portfolio called Fleetguard Fit. Fit stands for Filtration Intelligence Technology. And what that is essentially a real-time remote monitoring system that looks at the remaining service life of your filters on your engine. So that's your air, fuel, and lube filters. And we can also measure as part of that the oil quality or oil health. And so a really neat solution where, basically using some smart sensors, you can see in real time if there is a problem that is starting to develop, maybe some fuel dilution, or your oil is starting to fall out of range for some reason, out of its normal thresholds of total acid number, total base number, things like that. You can be alerted in real time and shut that equipment down, or have it serviced, or have it checked out, and that can prevent some very costly unplanned downtime. So if you're interested in more information about Fleetguard Fit, I would encourage you go to fleetguardfit.com, or again, you can go to the fleetguard.com website and look that up, or again, reach out. Happy to give you some more info there. So, folks, that's really all the information I prepared for our session today. We've got a few minutes here for some questions and answers. If I don't know the answer, like I said, I'm happy to reach out to some of our folks on the technical side of our business and get back with you. But if you've got questions you want to drop in the chat, or in that Q&A window, rather, I'm happy to try and take some of those now. Thanks. So the first question I can see there, do you have to change those lower viscosity oils more often? No, right? So that's part of that conversation, right? These newer categories of oils, they are formulated to last longer. That's kind of part of that evolution there with their formulations, their chemistry. So the base stock products are getting better. The additive packages are getting better. And so as these oil categories kind of move through time, through the American Petroleum Institute, kind of the industry for heavy duty engine oils, that is the intent. These are oils that even though the viscosity is getting lower, they're getting a little thinner. That helps with fuel economy, helps with emissions, and you don't have to change them as often. So there's kind of benefit all the way around here. So hopefully that answers that question. And Russell, yes, I am recording this. It will be posted back on the fleetguard.com website in a few days once our marketing team does that. But we will also be sending kind of a recap email out back to our attendees and those that registered. So be on the lookout. Any other questions? You are welcome, sir. No problem. Can you share your presentation with the customer? Yeah, as soon as the replay link is live, if you want to pass the link on and share it with folks, more power to you. That'd be great. I will say too, if you guys think of I'm not always great at thinking of questions on the spot. If you think of a question later on that you want to ask, please reach back out. I am not the expert on this information, but I'm going to learn together with you guys if you ask questions that I don't know the answers to as well. So, we want to be a resource for you in any way we can be. I will say, maybe while you're thinking about it, you should get an email that has a little bit of information, but and an opportunity to go and fill out our survey. It's a very quick little survey. Just let us know how we did today. If this was information that was useful to you or helpful, or if there's things we missed or corrections we need to make to this. We're just looking for some feedback. So you can scan that QR code here on the screen, or like I said, you should get a pop-up window that gives you an opportunity to fill this out. We'd love to hear from you. Love to get some feedback on the session. And if there's other ideas for other topics, filtration or coolant related, you'd like to hear about, please let us know. Yeah, so can you use the lower viscosity products on older legacy engines, such as a K series engine? Yeah, I would recommend talking with probably talking with the engine OEM. For legacy engines, I know generally, like those FA4 oils specifically, they are not designed to be backwards compatible, but the CK4 oils are designed to be backwards compatible to an extent. If it's some engine that's from 30 years ago, you may want to do a little bit of research there. But generally, if you go out and start looking at CK4 information on the API website. It'll tell you which categories of oil it's backwards compatible with. So if it goes back, the last 2 or 3 categories, that may fall in line with, an older engine like you're talking about. But that would probably be my recommendation. FA4, definitely not. CK4, possibly. You just want to see how far back that goes. So question here, and I'm at risk of butchering this. I'm probably not going to answer this fully, but what's the abbreviation for 15W40? And some of you guys on the call probably can answer this better than me. That does have to do with the viscosity, right? So I believe that first number, so W, it does not stand for weight. I believe that stands for winter. It all has to do with how that oil is going to behave at colder temperatures. So it has basically like a hot temperature and a cold temperature and what those viscosities look like. I would encourage you to Google that, look that up. I should know that a little better to answer your question. I'm sorry, I'm not sure who's asking here, but that does have to do with the viscosity of the products, right? So when you're talking about a 15W40 product versus a 10W30 versus a 0W20, it all has to do with the viscosity of the product itself. So usually, generally, the lower the number goes, the lower the viscosity or more runny, essentially, that oil is versus being thicker, and kind of think more like water versus honey, right? That viscosity plays a big part of the performance of the oil. It's a good question. Not trying to rush anybody. We still have a few minutes for questions if anybody has any questions. I do want to let you guys know we've got a couple more sessions left through the end of the year. So we're going to be back again on November 21st. That's a Thursday, same time. We're going to be talking about fuel systems and fuel filtration. This is, to me, really kind of the battlefront in terms of the filtration world today, for engine applications. Fuel systems, most critical system on an engine, and the protection requirements needed for those. We're going to get into that a little bit, some backstory on high pressure common rail, and definitely getting into the filtration discussion. And then our last session is going to be Wednesday, December 5th. Again, also at 10 a.m. Central Time. We're going to be talking about bulk fluid filtration. So this is going to cover a little bit of some different product lines that are kind of all encapsulated in, how do you take care of bulk fluid situations. So, a lot of that discussion will probably be bulk fuel. So if you're a customer or have customers that have, large bulk fluid storage tanks, holding tanks for diesel fuel, essentially what are good housekeeping practices for keeping that fluid clean and, preventing issues of equipment that may be filling up out of those. So that'll be a lot of our discussion back when we come together in December. Not seeing any other questions come through, so I'm going to go ahead and pull the plug today. Guys, I want to thank you so much. Really appreciate your time and attention. Hope to see you back in November for our next to last session for the year. And like I said, if you've got any questions that you think of later on, please don't hesitate to send a note over. I'm happy to be a resource and support you guys in any way that I can. Thank you so much. Hope you guys have a great rest of your day and great week. Thanks.